Let's look at structural or constitutional isomerism. Structural isomers are compounds that have the same molecular formula but different structural formula. By structural formula, we mean atoms in the molecule are connected differently. So, an example from class, if you had C4H8, so if that reminds you that this is CnH2n, which is alkenes, but also cyclic alkanes have the same general formula. So you have 4 carbon atoms and 8 hydrogens. We are trying to find all the different ways in which you can make the structure of this compound. Now there is no formula to determine the total number of structural isomers that can be formed from a given molecular formula. They have to be drawn out by trial and error. So let's first start with 4 carbons in a chain, 2, 3, 4. And now we know that this is an alkene, so let's place a double bond here. The way I find the easiest is to go systematically one at a time. So what else can I do? Well, I can have the 4 carbon atoms in a chain and I can move the double bond to the second position. So this was 1 butene and this is 2 butene. Well, then I can say, okay, I'll keep this here, and what if I move this to the third position available to me? As soon as I do this, I see that this is again 1 butene. So one thing that can help you on a test is to write names. So you see 1 butene, 2 butene, and then as soon as you draw this, you see, well, this is also 1 butene. So that tells you that this is not a new isomer that you have drawn. This is the same compound. So let's go on to figuring out what else could be done with this C4H8. Now let's get to cyclic compounds. So if you had a cyclobutane, there is a CH2 group at each node. So this is also C4H8. The name is cyclobutane. Sure, that works. Then let's see, what else can I do? What if I had a 3 carbon chain and put a methyl group out? If you're not sure, you could go in and write the condensed structural formula. So this would be CH2, but here you would only have CH and then CH3. So that is also C4H8. But the name this time would be methyl cyclopropane. So there you have all the possible structural isomers for C4H8. Let's try something else with 4 carbon atoms. It is in your geometric isomers practice 3. Geometric isomers practice 3. So it says how many non-cyclic constitutional isomers exist. So let's again start. So C4H7Cl, this is similar to what we were just doing with from an alkene. You've removed a hydrogen and added a chlorine. So there's a substitution reaction which we will learn later, C4H7Cl. So again the same idea, 2, 3, 4 carbon atoms in a chain. I have a double bond here, and now I can think, where all can I put the chlorine? So, well, let me start by putting the chlorine in the first place. And then let me go 2, 3, 4, 2, 3, 4, 2, 3, 4. I'm just going to draw out a few. So I keep the double bond at the carbon 1 and 2, and maybe I could put the chlorine here. I keep the double bond constant and shift the chlorine here. Keep the double bond in the same place and shift the chlorine here. So the names are 1-chlorobutene, 1-butene or but1-ene, however you like it, 2-chlorobut1-ene, 3-chlorobut1-ene, and 4-chlorobut1-ene. So those are the first 4. Now I say, okay, can I move the double bond around? So 2, 3, 4. Let me put the double bond in between carbons 2 and 3. Let me repeat that. See, can I maybe get 4 isomers in this case as well? Let's see. So I start with chlorine at the first position. So the name becomes 1-chloro-2-butene. They're both okay. You can write but1-ene or but2-ene. It's okay. Then I say, okay, let me move the chlorine at the second position. So far, so good. 2-chloro-2-butene. Fine. Can I make a 3-chloro-2-butene? Oh, wait a second. If I do this, I should number from this side, which is again 2-chloro-2-butene. So no, that does not work. Can I make a 4-chloro-2-butene? Well, again, I should be numbering from this side, which would again make it 1-chloro-2-butene. So that does not work. I need to try something else. Well, I have exhausted all possibilities for a core carbon chain. So let me try a 3 carbon chain. Okay, so let's put the double bond here, and now I need to make space for a chlorine and a methyl group. So how about I leave the chlorine constant and put the methyl group here. What do I get then? Well, I am getting 2-chlorobutene. So that does not work. So this is where I said it is all trial and error. Let me make all possible 3 carbon chains, and then I will show you how some of them end up being duplicates. So I had tried putting, let me keep the chlorine in one place and let me put the methyl group here. Does this work? Yes, it does. 1-chloro, 2-methyl-propene. That's a new compound. Okay, let me keep the chlorine group here and say I move the methyl here. Does that work? Well, it is the same as 1-chloro, 1-butene. So no, that does not work. What if I move the chlorine to the last carbon here and give a methyl group here? Is that a new compound? Yes, it is. It is 3-chloro, 2-methyl-propene or prop-1-ene. I think that's it. There are no more compounds to be formed. Hopefully you get the idea that you have to go one by one. Now let's just, for funsies, look at how many of these could have cis trans. I guess that is one of the questions. So not just for fun, how many of these isomers have geometric isomerism? And so let's figure out if it has cis trans or EZ. So let's do that. So here, yes, geometric isomerism. So yes, GI, and what kind? It could be cis trans. The second one, well, there are 2 hydrogens on this carbon, therefore no geometric isomerism. Same problem, 2 hydrogens on this carbon, so no geometric isomerism. 2 hydrogens on that carbon, so no geometric isomerism possible. In this case, yes, you can have geometric isomerism. So yes, yes. Look here, there is different groups, but these 2 groups are both methyl groups, therefore no geometric isomerism possible. And here there are 2 hydrogens on one side, therefore no geometric isomerism is possible. And there's another part to that question. It says how many cyclic isomers exist? Again, no formula to figure out how many cyclic isomers exist. We have to actually try making them and see how many we can find. So the formula was C4H7Cl. So let's start with making a 4 carbon cycle and put a chlorine on that. So this is chlorocyclobutane. Then what else can I do? Well, if I keep the 4 carbon chain and start moving the chlorine around, I'm really not getting a new molecule. So I have exhausted the possibilities of what can be done with a 4 carbon chain. Then let me say, okay, how about if I go to a 3 carbon chain? Okay, let me make a 3 carbon chain. Let me put a methyl group here, and then let me also put the chlorine group on this side. So the name would be 1-chloro 1-methyl cyclopropene. What else can I do? I can keep the methyl group at this position, but I can move around the chlorine group. So I would get 2-chloro 1-methyl propene. Actually, chloro would get 1 numbering. So if I were to number this, I would have to give chloro the 1 numbering and the methyl group the 2 numbering. So this would be 1-chloro 2-methyl prop-2-ene. So this would be 1-chloro 2-methyl cyclopropene. What else can I do? I can have the 3 carbon chain, keep the methyl group here, and then if I move the chlorine group to the 3rd position, have I created a new molecule? No, it's the same as this, because I could start the numbering here and I would still get 1, 2. Okay, so this is the same compound. I have not created a different compound. Let me keep going. Have I exhausted the possibilities of everything with 3 carbons? What if I put the methyl group and then I put the chlorine group on top of the methyl group? So then this would be 1-chloromethyl cyclopropane. And I want you to notice the difference. So this is 1-chloro 1-methyl cyclopropane, whereas this is saying 1-chloromethyl. That means the methyl group I apologize. The methyl group has a chloro group substituent attached to it. So there is a difference in the names here. 1-chloro, 1-methyl or 1-chloromethyl. They are two different entities. Another way to write that could be the chloromethyl part could go in brackets because that is a complex group. What am I missing? Let's think. 1 second. Okay, I'm not seeing any other possibility. If anyone sees another option, please let me know. So I think let's stop here. Good luck for your quiz.